Perfect. Thank you, Patrick. Really, really interesting results there. I'm just gonna spotlight all the speakers, and then we had a couple of Q&A as we went through. So I'll read those, and then yeah, if anyone has any other questions, feel free to post them as we go. So I think we had one, I think Arthur during your presentation about what's the distinction of printing with regrind and pellets. So I don't know if you can pick up on that one first.
Yes. Yeah. So for clarification on that, yeah. So when we're talking about regrind, we're talking about basically the flakes that you end up with after the granulation process. And so we're literally talking about tipping those flakes directly into the hopper and printing with them directly. So where we found that approach was feasible and was successful is where we were able to control the particle size distribution by sieving. So in our experience with this particular extruder we have, which keep in mind it has a 25 millimeter bore size, and you want to allow that regrind to be able to flow easily into the flanks of the screw. So controlling that particle size distribution is really important. We found that if you sieve to get the longest particles to be within 6 millimeters and above 1 millimeter, then they actually feed really consistently, much like a pellet would. So obviously, yeah, in most cases, it's normally necessary, as Thomas explained as well at AirTech. The way they do it is to repelletize. You can actually get some surprisingly good results just with regrind.
Oh, thank you, Arthur. And then we did have one more again. It was during Thomas's your presentation. So, what are the process parameters likely to affect the performance in these cases? With the scale of the printed geometry, does environment, e.g., humidity, temperature, air quality, have considerable effects? You're on mute. Sorry, Thomas.
Sorry. Effect on what?
I guess on the what it's basically asking what process parameters will affect the performance. So does it, with the large scale geometry, does environment have an impact? Yeah.
Temperature of the environment, humidity, of course. But yeah, I think the temperature and humidity are the two main factors of the entire printing process. I wouldn't say it doesn't really depend on material in general.
Okay. And then Steve has just added one. Do you ever have to add support material to the build? I guess that's to maybe all of you there. I'm not sure.
For build?
Yeah, for the build. I guess if you're building these large structures, the question is, do you have to add support material?
I mean, we've done it, and we did it in the past. Sometimes we orient the print to have the best, say, CTE performance. It means that we print under 45, but some geometries are impossible to print under 45. Then we add a support material, but it's not I would say the general approach.
Okay. We've got one more for you, Thomas, and then one for Patrick. So for AirTech pellets, do you have a moisture weight for each material that we should not overpass or go? Yeah.
Yeah, we do have a minimum moisture content, maximum moisture content that you should not pass. It's in our extended data sheets. So if you reach out to me via email, I can share that with you.
And then for Patrick, is there an ideal travel speed for the extruder with the LEAM system heating to give enough time for the surface to be reheated?
Yes. So it's tough to give kind of what one size fits all answers to this. It depends on how big of a jump you need in temperature. So if you have a print that's running continuously, you're close to the limit of stability, you typically only want to go up by, I don't know, 100 degrees Celsius maybe. If you're printing onto something that has already cooled down to ambient temperature, for many materials, you need a much larger jump. So for PEEK, for example, we go up to 390 degrees sometimes. So depending on how big this jump is, you'll need to go you need to go slower or faster. But the system self-regulates. So if we notice that we're at the limit of LED power and we're not reaching the temperature, the machine will also slow down to give the material more time. So it will adjust automatically.
Okay, great. So there's a couple more questions, and then I appreciate we're pushing into 1 o'clock, so we'll do 2 or 3 more, and then we'll close. So we might be able to get your question as well, Evan. So for Dylan says, for the DMEX system, will angular prints be able to be done given the attachment to the print head? Because that's for you, Patrick. Yeah.
Yeah. To a certain extent. So the ones in the picture so far were our first design iteration. The next iteration has a little bit more freedom around the nozzle. So the one that should be coming to MTC later this year will allow for just over 30 degrees tilt angle. So the typical 45-degree printing with that one is limited. We are starting design on a 45-degree version of it, but most likely that will have slightly lower kind of power density on the part, just because of the way the optics work. So yeah, there is a certain limitation to how much you can tilt the extruder at this point.
Okay, great. We will take just a couple more as we're a couple of minutes. So has any work been done on the material CTE values in real-world autoclave environments? That's from Graham.
Sorry, if there's any work done on the materials regarding the CTE?
Yeah.
Well, each material has different CTE. There are, I would say, the best option for where you count on CTE are the high temperature materials like PI and PSU. So yeah, the CTE is known. The CTE is different than injection molding material grades. The CTE is in X and Y direction is pretty much the same. In Z direction, it differs a little bit, but you can compensate it and you can get the desired shape at the end of the day. I mean, in 99% cases, 95% cases.
Perfect. Okay, just there's one more for you, Arthur, in terms of have you tested a regrind with virgin pellets? So has that been tried?
Yes, and is there a risk of separation in the feed system? So yeah, it's a really spot on point. So I would say that the way that we envisage this being implemented in production is with most likely one hopper for virgin material and one hopper for regrind. And we're aware of systems that allow you to proportionally mix materials at the point of need before they come into the extruder. Otherwise, what I can say is that when we're doing this kind of test at a lab scale, really careful and mindful of the separation of bulk materials, which of course have different particle sizes. So you'd expect, for instance, the fines and smaller particles to sort of stick to the sidewalls of equipment, especially where there's any electrostatic discharge kind of issues, and those smaller particles just love to stick to things, especially when you've got polymer flowing through tubes and all sorts of things. So yeah, I hope that answers the question.
Perfect. And I think with that, I mean, there's a yes, no with the boxes that NLR had printed, were they open top or were they closed at the top? Is one. So
I think that one's
for you, Patrick, with a quick.
So the boxes were open at the top.
Okay, cool. And then could a plastic box with a hatch on top be possible? Again, just a yes or no?
Yes, with 45-degree printing.
Cool. All right, and with that, we shall, I think, close out the Q&A. So thanks again to all of the speakers, some really interesting presentations. I think, do we have a survey that's going to go out? So we'll be sending that out, and we will be sending as well the slides. All of the slides have been presented today. So yeah, if you sign up via the webinar, you will put your details in, and we can send those all out. So do watch out for all of those. So yeah, thanks to all, and I hope you have a great rest of the day.